and welcome everybody. Well, today we're going to talk about accelerating Microsoft SQL Server 2012. We'll talk a little bit about differences between SQL Server 2008 R2 and 2012. This is by no means a deep dive. We have 30 minutes and then some Q&A. So let's all buckle up into our Airbus 380 or Boeing 787, get comfortable, and take a look at this stuff from a 37,000-foot level. My intention when you leave is to have a stronger vocabulary with SQL Server 2012, so when you engage with customers, you're speaking the same language. So I hope to achieve that. So we'll talk a little bit about what is a database, hopefully not too high level. What's new with SQL Server 2012, some opportunities for acceleration through our Nytro Flash products, why use Flash at all, a little bit about the breadth of our Nytro product family, and then open it up for questions. So the world of data is changing. The volume, velocity, variety, and value associated with that data is changing. In order to remain competitive in today's environment, you really need to be able to apply business intelligence to your competitiveness in the market. And I'm not going to go over each of these buckets, but data is changing, both structured and unstructured data. Everybody has every device connected to the cloud or the internet, and we're all moving data to and from both unstructured and structured social data as well as business data. And it's very important to be able to get to that data as quickly as possible, and Flash is going to allow you to do that. I'll get into that in a little bit. Let's do a step back, understanding databases. Why worry about data relationships? Well, you know, a database is really a construction of pointers and data all combined together to be turned into information through automated processes. The analytics part of that is how you gain competitive advantages. So you'll learn about the relationship between the various data sources. Think buying something from Amazon, and it can dramatically influence a company's success. So when you talk to a customer about improving their database performance, you're really talking to them about improving their business performance, getting access to data as quickly as possible, eliminating bottlenecks, having very low latency access to media is very important to running reports, churning through piles and piles of data sets and data, and getting that competitive advantage that will take you to the next level to scale your business. At a high level, a relational database really creates a map of relationships between the various data sources or pieces of data. Of course, manufacturing production needs to understand the suppliers that they're dealing with and the products and SKUs and supplier IDs and all bits and pieces of data that to help set up the supply chain. There's all different types of categories, and that has to be connected to orders. So when you when you process an order, you have supply chain information. You're able to reorder and plan out via ERP your builds and how to get the products to market. Of course, that includes the ability for customers to order and for us to have products on the shelves and to reorder when inventories get low, ultimately churning into a commission check for a salesperson. All this stuff has to happen in a real-time environment that's constrained traditionally with spinning media, just by the simple physics of spinning media. And Flash will allow access to this data much quicker and eliminate lots of the pain points the database administrators deal with and IT managers deal with on a daily basis. I'm going to talk about basically two different ends of the database workflow. The front end, or OLTP, online transaction processing, think of Amazon e-commerce checkout portals, online brokerage applications, call centers, and ERP planning. There's a lot of data, a lot of users. It's typically smaller data set sizes, but real-time interfaces, because you're entering these orders, this data in real time. It has to be very quick. There's typically hundreds or thousands or millions of people transacting business through using OLTP types of applications. The pain points in an online transaction processing system include the inability to scale, the inability to add users because your hardware is constrained. poor user response times. This is the famous 3-second rule. If you're not getting access to a website or a portal or a checkout in 3 seconds, you start to lose interest in completing the transaction. That's certainly responsible for millions of dollars in an environment like an Amazon business place. End-of-day batches not completing. So if you're a grocery store chain and you're not completing your inventory runs in a window supplied by your DBA and IT management group in a certain amount of time, then next week you're not going to have Wonder Bread on the shelves. Maybe Wonder Bread is a poor example right now in today's climate with that company, but you get my point. Storage performance problems are often the root cause of this issue. Processors, memory are very high performance. Moore's Law has provided us with a very rich performance complex from the server side, but if you look over a stretch of 20 years, you see basically no improvement in disk. As a matter of fact, disks are getting bigger. The ability to get to that data is so difficult that companies traditionally over-provision their storage to get to the outer tracks of disk, which is just too costly to scale with. And flash will often provide the types of response times and low latency and performance that makes OLTP a more rich, scalable environment. The other side of that is online analytical processing, or OLAP. OLAP, the difference between OLTP and OLAP is OLAP typically has a smaller set of users with gigantic data set sizes. Now you're looking at all of the data that you've collected from all of your business, and you're mining it. You're going through and mining it and drawing or abstracting the business intelligence you need to remain competitive and to get all of your critical information understood so that you can make changes to your products, make changes to your inventories, make changes to your locations in order to remain competitive. So these typical larger data sets have a smaller number of users, but the pain points are basically the same. Query runtimes, ad hoc query runtimes. If these cannot be accelerated to some extent, you will run out of time because it can take hours to days to run in order to complete your reports. ETL, or extract, transform, load, is the ability to get all that information that you've collected with your front-end OLTP loaded into the OLAP environment. These are extremely large data sets that need to be loaded and then mined through. And again, storage is a very common performance limiter to that. So you'll see that there's opportunities to improve both OLTP and OLAP by using flash, and I'll get into that a little deeper. So we've talked about OLTP, we've talked about OLAP, OLTP being the front-end e-commerce, OLAP being the back-end standard reporting and ad hoc querying, large data sets, smaller data sets. Flash is kind of in the middle of all of this. Anywhere you see Nytro in this very high-level, simple database structure is opportunities to flash. So indexing, both B-tree, heap, or row-based indexes can be is very acceleratable. Column store indexes, which is new to SQL 2012, and I'll talk about that in a little bit, is a very acceleratable component to SQL Server 2012. Your data, of course, there's frequently accessed data and less frequently accessed data. Anytime you're looking at frequently accessed data, it's flashable, cacheable, acceleratable. TempDB, I'll get into that in a little bit, is another great opportunity to apply flash to a pain point and get the DBAs to bed on time every night. Availability groups is a new feature with SQL Server 2012. I'll talk about that. Of course, logging is also an opportunity for flash media, as well as anything that has to do with OLAP or OLTP processing. All right, let's dig into SQL Server 2012. Again, we have about 20 more minutes, and I hope you'll leave with a couple of new keywords that you can go research on and learn a little bit more about. Microsoft is very, very proud of this release, SQL Server 2012. They reached out to a broad set of customers, reviewed feature requests, what the pain points are, and they really did a forklift upgrade from Server 2008 R2 to 2012. As you can see from this slide, there's many, hopefully you can see from this slide that there's many features. I don't know if it's showing up or not, but there's hundreds of new features. All right, I'm going to focus on a few. The major components. So what Microsoft did is they took away 7 specific elements to improve in SQL Server 2012, and they focused on those elements. So I'm not going to talk about all 7. I'm going to talk about the ones that make sense to Flash, and that's some availability features, some scalability features, of course, performance, and TempDB. I cannot emphasize enough TempDB. This is a very rich opportunity for Flash. So some of the availability enhancements include this concept of always on. And always on has a lot of different features that provide availability enhancements. There's this concept of availability groups, which I'll talk about in a second. This concept of failover cluster instances, or FCI, which I'll talk about, and support for Windows Core. The reason Windows Core falls into this availability enhancement category is that Windows Core is a scaled-down kernel from Windows Server 2012. It's very important in a SQL Server environment to have a very thin kernel to process only those things and to serve only those things that are most important to the environment. So you don't need rich GUIs or graphical user interfaces. You don't need a lot of that stuff. But what you do need is the ability to cluster, the advanced security that comes with Server 2012. You need all that stuff. So you've got a scaled-down core that you could use underneath SQL Server 2012. Let's talk about SQL Server 2012 availability groups. The change here is that it allows multiple databases to fail over as a single unit, rather than each database instance being failed over at once. So you can see how this provides availability, accessibility, performance improvements to the databases themselves. It supports up to 4 secondary replicas. So 2 of those replicas can be synchronous commit replicas, and 2 can be asynchronous replicas for long distance disaster recovery. The important piece here is that all of the secondary replicas are active and readable. So while you're processing your front-end OLTP data, your back-end OLAP or reporting or backups can be processed from these replicas, and they're real time. All right, so Microsoft claims that using synchronous commit mode on 2 of the replicas, you actually provide 0 data loss protection in disaster scenarios. All right, so this is a very important feature, and so why am I talking about that with Flash? Because with Flash, and we showed this recently at our own trade show called AIS, we showed this running a couple of Nytro Mega RAID cards, which is really a combo card that has the ability to RAID protect hard disk drive storage and provide integrated embedded acceleration through the use of Flash. In this particular demonstration, we had Mellanox high-speed RDMA I/O adapters, which provided that very low latency, near zero commit between the server instances. So you got a primary node and a secondary node. The primary node is read-write to your database. The secondary node is read-only, and you can perform all those critical functions and still get acceleration through caching on reads for OLAP processing. And on the primary, you get acceleration through Flash for both write and read processing in your SQL Server 2012 environment. That's a very powerful combination. In a nutshell, we took SQL Server's always-on availability groups. I see it hasn't refreshed. So I'm going to try again here. There we go. We took SQL Server's always-on availability groups. We used Nytro Mega RAID. We cached the frequent accesses to the hard disk drive, both on reads and writes in the primary and on reads on the secondary. We provided high availability through the use of mirroring database logs over the Mellanox InfiniBand interconnect cards. And we have a very economical, high availability always-on SQL Server 2012 primary, secondary, clustered database environment. This is a very, very economical way to provide high availability, flash acceleration, and RAID-protected storage in a SQL Server 2012 environment. SQL Server 2012 always-on FCI, or failover clustering instance. The big difference between this and SQL Server 2008 R2 is now it supports multi-subnet failover clusters. So where you were constrained to local subnets in a single data center, you can now extend those subnets over long distances and get that failover, that high availability clustered failover, across long geographies. So it's either local or remote and geographically separate locations. So you've got multiple instances of your database across long distances. This allows you to get faster startup and recovery after failover. The big takeaway to all this, and I think I've underlined it, and I see it's not coming up, but the underline is Flash TempDB can be local to each cluster node. With SQL Server 2008 R2, TempDB was on spinning media, in a SAN, on shared storage. Excuse me. You now get the ability to have TempDB on each local and long-distance instance of your database. So why is TempDB so important? I'm going to get into it in a little bit, but think of spillover from memory typically has to go somewhere, and it's called TempDB in SQL Server 2012. TempDB, if it's constrained to spinning media, that means your indexing in memory would have to go out to the SAN, retrieve additional data or update additional tables and records, and then come back into memory. That introduces a very long latency time. By having it remote and on flash in your system, TempDB now has that low latency, high performance, non-mechanical performance improvements over hard disk drives local to your database. So you get improved cluster health detection policies, and of course TempDB no longer is required to be in shared storage. That's a very important takeaway when you're talking to customers about failover clustering. I'm getting questions through the chat, and I'm going to answer those after the end of the webinar. Good questions. I talked about Windows Core. Basically, I talked about the improvements and the value of having a very thin kernel. Really, the reality, though, is it uses 50% less memory and disk space, which is a TCO benefit, as well as a better security, better clustered failover support, and all the other things, command line interface for management. It's a much thinner core, and it provides TCO benefits to your customers. So talk to them about using Windows Core if they don't need to have all those GUIs. SQL Server 2012 performance and scalability. I'm going to talk a little bit about column store indexes and the differences between heap or row versus column. Increased partition size support from 1,000 partitions to 15,000 partitions. This is just basically a scalability value proposition. It allows you to create more volumes, more partitions to manage your databases more effectively, and it scales from 1,000 to 15,000. Big improvement over Windows 2000 or Windows SQL Server 2008 R2. And of course, I'm always bringing up TempDB. This is the first and foremost, most critical component for flash acceleration. Column store indexes. This is used for big data, or OLAP. It's much different than your traditional database indexing, which is called row or heap. Column store is an in-memory index. It's built directly into the relational engine. So it's moved from disk pages into memory and processed in memory. Data is stored in columns, not rows, and there's a big advantage to that when you're mining big sets of big data. Each column is stored on its own page instead of all the rows and columns being stored on the page itself. It's similar to an Excel pivot table. So think about that analogy, how a pivot table allows you to get only the data that you really need and filter out everything else. Column store allows you to do that in SQL Server 2012. Column indexes are highly compressible because there's a lot of similar data in columns rather than in rows. It's highly compressible. The more compressible the data is, the higher performance benefit you're going to get from LSI Nytro products. We use transparent compression in our flash management controller chip in order to reduce the write amplification, increase the write endurance of the SSD itself that's integrated onto our cards. So compressible data is great. Incompressible data, we're still as competitive as anything out there, but just with 10% compressibility, you get enormous improvements in performance with Nytro products. We've looked at many databases. Roughly 50 to 70% of all databases are compressible in some form. So this is a very rich opportunity for LSI Nytro acceleration. Non-clustered indexes are assigned to specific SSD volumes. So non-clustered indexes would be column store indexes. Microsoft claims that because they're using in-memory indexes, that you'll get a 10 to 100 times in performance improvement from column store before flash is even applied. So you get that added benefit of low latency flash to an already enormous improvement in indexing with column store over row. Now, column store will not work for OLTP types environments. It's for OLAP environments. And there's an engine within SQL Server 2012 which selects the correct indexing depending on the type of data access that's being applied to it. If we were to look at this graphically, column store versus row store, in a row store heap or B tree, entire data pages of data are transferred from spinning media into memory and is used for updating lots of rows and records, lots of rows and columns, lots of data, lots of records. The tables are constantly being updated. Because think of buying or applying e-commerce to this. There's lots and lots of data that needs to be updated. When you buy something from Amazon, your account and the account of millions of others at the same time are being moved from one location to the other and updated, both with writes and read as well. In column store, for big data, you only need to look at certain types of data structures. It could only be the product ID, the order date, and the cost. And on the right, you'll see the difference, how everything is moved from memory. Even though you don't need everything in rows, everything is moved for updating. Because column store is used for OLAP, and OLAP is 90% read, they only move in the data that they need, or the columns that they need. Then they have pointers to where the data is. This is a highly compressible format and highly acceleratable through flash. Both of these are. So you get row store because we're caching. If you're using our caching products, you're caching the data itself, and with the data you get the indexing. And column store, you can create the volumes for column store to get the benefit of flash. Okay, TempDB, I keep talking about this. It's not a new feature, but it's very acceleratable. It used to be in shared storage only. It's now local to each server itself. So you could have a Nytro flash product in all of your servers, both redundant servers, replica servers, as well as primary servers. When operations exceed the memory allocated, SQL overflows to TempDB. And if you could imagine a server having to go out to disk to update records or to bring new tables or records in and update logs, it takes a long time relative to the processing that needs to be accomplished. So if you can create TempDB on flash, you eliminate the added cost of adding memory, which can be 4 times as expensive as flash, DDR3 1888, and you get that low latency, high performance benefit of memory in a flash package. So assigning TempDB to flash restores near DRAM performance at 1/4 the cost. All right, I'm going to talk about the products really quick here. We have 5 minutes. All right, so there's this data deluge. So the increasing enterprise requirements as flash moves from consumer to data center means increasing writes, higher reliability, and more performance. On the flip side of that, cell geometries on flash are continuing to shrink. So you get less writes, you get lower reliability. So how do you connect those two ends of the problem? Increasing writes in the enterprise, but cell geometries, the trade-off on higher capacities, lower costs, is less writes. Will you use a flash management controller? That's the best in the business. LSI acquired SandForce earlier in this year. We've applied SandForce technology, who is the market share leader, to all of our products. So you get the benefit of enterprise-level cell management or NAND flash cell management through our SandForce technology. There's lots of great value and benefits. Please talk to your sales rep about what those are. Why flash? There's a 5 orders of magnitude gap between main memory and Tier 1 storage. That is the rich opportunity for flash, and that is where flash is solving problems in OLTP, OLAP, and basically any type of database environment where you need very high IOPS, very low latency to increase your transactions or reduce response times and increase the user count. We segment our controllers very simply. We have Nytro Megarate, which is HDD flash. We have Nytro Warp Drive, which is primary storage. And then we have Warp Drive XD, which is caching capabilities. DAS acceleration with Nytro Megarate or Nytro Warp Drive. You could use a Nytro Warp Drive as a replacement for disk if you choose, and some environments can absorb that cost just due to the benefits of the low latency, high performance. Or you can use Nytro Megarate to protect your data with RAID and get the same types of caching performance through integrated onboard cache. Or in SAN environments, you could use it for SAN-side acceleration or server-side acceleration connected to SANs. And our XD software is agnostic to the I/O, to the application, to the operating system, to the file system. It just looks at frequently accessed data, places that data in flash if it's in the form of XD. If it's frequently accessed read data, we move that into flash. We allow write data to be write through. And in the Nytro Megarate side, we cache both write and read data, and we manage all of the coherency with the hard disk drives ourselves. There's 3 use cases. There's the far left, which is primary storage or manual placement of data. A lot of customers will use flash and then use embedded caching capabilities in the operating system or applications, or they have high IT spend resources with DBAs that can fine-tune applications to take advantage of flash. The center is if you don't have IT spend, high IT spend or high DBA spend, and you want that same benefit that you get on the left, then allow Nytro XD to manage your data traffic for you. And we'll place hot data into flash and allow the cooler data or the less frequently accessed data to go to a hard disk drive or SAN. In the far right, it does the same thing as the center, but it's for DAS. So DAS protection and acceleration. That's how we segment the products. On the warp drive side, you can accelerate TempDB. We talked about that. Accelerate column store indexing. We talked about that. The center, you could accelerate B-tree or row or heap indexing and accelerate data itself using XD software. Very low cost, very high performance. In Nytro Megarate, you could accelerate those availability groups, and you get the benefit of both DAS, RAID protection, and acceleration. All right, I'm going to briefly go over the benefits. Fast, smart, and easy. Fast, 2 gigabytes per second, less than 50 microsecond latency on average. It's a bootable, it's battery-less failover, it's very high performance. It's built on 30 years of storage expertise from LSI. It's very smart. I talked about SandForce technology and its features like DuraClass and seamless or transparent compression, ECC protection end-to-end, RAID-like protection against NAND cell media errors, and field tested across multiple server platforms. It's very easy. You basically install it and let it go. There's no big management effort to get in this thing to perform. The types of performance over our competition is seen here. With just 10% compression, we get almost 2x the performance. With 50% compression, which is very typical in a database environment, we get 2.5 times the performance. Nytro XD is that caching software layer, seamless integration with existing storage. It's read-only caching, so don't worry about the security and protection of the data on disk. The worst that can happen in case of a failure is you lose your read acceleration, but you could rebuild that with a replacement or spare. No change to existing infrastructure is required, zero admin overhead, and you could actually populate servers with multiple warp drives with only one XD license. The types of improvements you could see, this happens to be Oracle, is of course reduced response times on the top and improved transactions per second on the bottom. All right, I want to get the questions. Nytro Megarate has all those same benefits in a DAS environment. So I'm not going to go over all these, but you get all the same benefits, including RAID protection through Megarate, our industry de facto standard RAID stack Megarate. The value, of course, again, is fast, smart, and easy. This thing is ready to go. You boot it up. You assign the caching layer to the volume you want to accelerate, and off you go. It's very simple. You don't have to use a battery backup, a lithium-ion battery, or a supercap with this product. If you're using it in a database environment, you could turn our DRAM caching off. You don't need it. Use write-back caching through NAND flash, and it's persistent, no battery required. Anyone who has used Megarate or any other RAID controller in the industry, this is a big pain point, batteries and DRAM protection. You don't need it with Megarate, with a Nytro Megarate card. The types of benefits you see are similar to the XD. TPCE performance during rebuilds. This is another orthogonal benefit you get with Nytro Megarate as data is being served through the flash. It allows our RAID processors to manage rebuilds much faster. Nytro Predictor. Anyone on the phone who hasn't used Nytro Predictor, get a hold of your sales rep, ask them for Nytro Predictor. It's a free download. It's available to analyze and assess workload environments without hardware. You don't need any LSI hardware in it to assess and analyze and recommend the type of Nytro products that would fit in the environment. This is a free download. It's a big, big deal. We're going to have a follow-up webinar on Nytro Predictor as well. All right, I went through a whole lot of stuff in 33 minutes. I know it's a lot of stuff. I hope you come, leave the webinar with a little better vocabulary around SQL Server 2012. These slides will be made available to you. I'm now going to take some chat questions, Emma, and then we can open up the phone lines. Does that sound fair?